Renee!
Okay, so today we're going to do synthesis of this thing. This is a triple bond. We're trying to make that as a pentagon. And then this is a phenyl group over here. And then we have an epoxide. Okay, so now we're going to do that. So to start out, we have our alkynes, sorry. And we're going to take that. And we need to add this phenyl group over here to the right side. So we're going to use our base, our favorite base, NaNH2, and then we need to add the phenyl group. I really wish I could draw phenyl groups. And then you have to have the iodine on the end so that it will do a SN2 reaction. And so when we do that, you get this thing.
You can start and stop and pause it. Right, so he's like, here's the question, we're thinking about it this way, and you explain what it
Alright, cool. So the next step is then we need to get the left side of this big old molecule over here. We need to get the left side onto the molecule. So we are going to again add NaNH2, our favorite base again. And then we need to add this pentagon, sorry. And we're going to put a aldehyde on the end. And then we also need water. And then when you add that, you get an alcohol because the negatively charged base on the NaNH2 is going to attack the bottom of the oxygen, and then the double bond is going to come up. So then you need the water to protonate the oxygen, so you end up with an alcohol. And so we get this pentagon over here with this alcohol coming, oh that's terrible, with this alcohol coming out of it. And you still have your triple bond. And then over here you have your phenyl. I'm just going to write pH for now. Alright, so now we need to get rid of the alcohol to make a double bond, because if you can tell up here in the beginning molecule we have an epoxide, and so to make an epoxide we need to have a double bond, so we need an elimination reaction. So in order to do an elimination reaction we need to do an E1. We're going to use H2SO4, so we're going to take this molecule over here and put it over here, and we're going to do H2SO4. And that will give us the E1 reaction that we need, and give us a double bond right here, and get rid of that OA, get rid of that alcohol group. And we still have the triple bond and the phenyl. The pH is for phenyl. So once we have that, the way we know to make an epoxide is using a reagent called MCPBA. That's not look good. Sorry, I messed up. No, I don't want a stylus, Dr. G. MCPBA. And so once we use MCPBA, we're going to get the lovely epoxide that everyone just loves so much.
Or hates.
Or hates. But don't hate on epoxides, that's rude. And so we're going to get this epoxide. And so the last step is to get rid of this triple bond and make it a double bond. But if you remember, we cannot use Lindlar's catalyst because that would give us a cis, And we, as you can see from the beginning molecule, we need a trans. So in order to get trans, we're going to move this guy over here. In order to get the trans double bond, we're going to use sodium metal and liquid ammonia. And that will take this triple bond and turn it into a double bond. And then we end up with our epoxide and our double bond. And then our lovely phenyl group. And that is the answer. Thanks to Dr. G for all of the help.